It turns out that we're usually going to assume that the shape of the isoquants is not only downward sloping, but also convex. Just right. So this might be 10 bushel isoquant, this might be 4 bushel isoquant, this might be 20 bushel isoquant. The shape doesn't have to be convex, but we're going to assume that it usually is. So let's discuss the implications of this assumption. Suppose you're over here. That means you're using lots of water but very little fertilizer in order to grow corn. And what happens if you take some of this fertilizer away? Well, you were using very little fertilizer to start out with, and now you've taken some of it away. The idea is that that has decreased corn production a lot. And so in order to get corn production back to where it was before, so you can draw the isoquant, you're going to have to increase water a great deal. Remember, we're assuming throughout here that increases in water increase corn output, and increases in fertilizer also increase corn output. As I mentioned before, that's not always the case, but we're going to assume that it is the case. If it's not the case, then you end up getting isoquants that look pretty similar to some of the examples we drew of indifference curves in situations where increasing one commodity or the other didn't make the consumer better off. In any case, here decreasing fertilizer has decreased corn output quite a bit, and so to compensate you have to put in a lot more water. And therefore the slope here is pretty flat. Whereas if you go to a point in the upper left, here using very little water and lots of fertilizer, if you take some of the scarce water away, that's going to decrease corn output a lot intuitively, and therefore in order to compensate to get back to the same isoquant you had before, you're going to have to really increase fertilizer a lot. And so the slope up here is quite steep. We have a name for the slope, or actually a name for -1 times the slope. -1 times the slope of an isoquant is called the rate of technical substitution. Of whatever is on the horizontal axis, I call it W here. I put W on the horizontal axis. For whatever is on the vertical axis, and I put F on the vertical axis in this example. The abbreviation we're going to use is RTS of W for F. And sometimes I don't write of W for F, I just write RTS. So that's the rate of technical substitution. Pretty clearly, it's analogous to the marginal rate of substitution in consumer theory. With this definition, let's see how the rate of technical substitution behaves in an isoquant that has the typical slope. So in the upper left, the typical shape, I mean. So in the upper left, let's see what the slope of the isoquant is. If this, let's say, just arbitrarily is 1, then this perhaps is 2. So rise over 1 would be 2. This is obviously a negative slope, so we have a slope here equal to -2. On the bottom right, let's see, this might be maybe 4. And let's call this 1. It's probably less than 1. So the slope here, the rise over run again, would be -1/4. Now let's see what the rate of technical substitution is. So the rate of technical substitution is minus the slope of the isoquant. So the rate of technical substitution here is +2, and the rate of technical substitution here is +1/4. So what you see is that as you go from left to right, the rate of technical substitution starts at something like +2 and then it ends up at something like +1/4. So as you go from left to right, we have diminishing, you could also say decreasing, rate of technical substitution. And that is characteristic of convex indifference curves. Convex indifference curves are always going to have diminishing rate of technical substitution of whatever's on the horizontal axis for whatever is on the vertical axis. By the way, as something of a footnote, it turns out that the rate of technical substitution of W for F equals 1 divided by the rate of technical substitution of F for W. I'm not going to expect you to know that, but it could come in handy. In other words, if you happen to switch F and W on the axes, since after all it's completely arbitrary which you put on which axis, then you'd get the natural thing to look at would be the rate of technical substitution of what you've put on the horizontal axis for what you've put on the vertical axis. And the relationship between those two things is given by that reciprocal.